which this is actually our most recent content that we learned, the complex solutions for quadratics. So hopefully this is still pretty fresh in your mind. What are the complex solutions to the following equation? And remember, this reference sheet that I gave y'all last week, and I told you you can make notes on here, you can highlight, you can write things in the margins, whatever you want to do, and bring it back with you and get to use it on the test. Okay, it's got the quadratic formula on it. If you want to add any notes around the quadratic formula, like the square root of -1 is I, or ax squared plus bx plus c, like so you know where a, b, and c are coming from, you can be adding any of those notes to this reference sheet and you get to bring it back and use it on the test. So just keep that in mind. Okay, so we could see the, these are in the form ax squared plus bx plus c. So we are going to identify our a, b, and c. So a is an understood 1, b is the -2, and c is a +3. So then we are simply plugging them in to the quadratic formula. So it's -b plus or minus the square root of b squared minus 4ac all over 2a. Now when I simplify this minus negative out here, that's going to become a +2 plus or minus the square root, and then my denominator is just going to be a 2. So now I'm just going to simplify what is under the radical. So I'm going to come to Desmos and type that in, or you can do it in your head. It doesn't really matter. Okay, but we are calculating, or maybe I closed Desmos. Open a new window with it. We zoomed in. All right, so I'm doing -2 squared minus 4 times a, which is an understood 1, times c, which is 3. Okay, and you get -8 when you calculate that. So your discriminant, that's the name of that number under the radical, is called the discriminant here, is -8. Okay, so the discriminant is negative. These are the types of notes you may want to add to that reference sheet. When you have the square root of a -1, that's I. That's where the I is coming from in these answer choices. So I'm going to replace that negative under the radical with an I outside the radical. So I'm going to rewrite this. And I'm also going to simplify. I'm going to do two things here. So there's going to be an I outside the radical. And if you look at your answer choices, notice they're putting the I in front of the radical. That's fine. You can do that. Or you can write it after the radical. It doesn't matter. But right away, I can see this last one has the I underneath. I know that's wrong. D is out. B is out because there's no I at all. Okay, so I'm down to 2 choices, but I still need to simplify that square root of 8. So I would do a factor tree. And I'm looking for pairs. So a pair of 2's. So a 2 gets to come out. And then this 2 does not have a partner, so it has to stay underneath. So then we can simplify our this gets divided by 2 divided by 2 is a 1. Okay, this 2 divided by 2 is a 1, so I'm left with just that I root 2. So just 1 plus I root 2 is what it came out to. Okay, so this is quadratic formula, and you've got to understand when the discriminant is negative, your answer is going to have that I outside the radical. All right, now number 33, it says a company is analyzing the relationship between their advertising budget and the resulting sales revenue. The data they collected from the past advertising campaigns is below. To maximize the company's revenue, how much should they be spending on advertising? To maximize is the key word. So they are looking for the maximum of this quadratic. Now we have the data, we do not have an equation, so we are going to use regression. When you have a table of data but no equation, this is when regression comes in. And there's the quadratic regression steps here on that reference sheet. So I'm going to come into Desmos and I'm going to add a table and I'm going to input my data. So 8, 12, 18, 40 for my X's, and then 802, 850, 892, 898, and 738. Now, when we learned regression and what the steps for regression said to do was then to type this in as Y1 and then use the tilde, and then it doesn't say anywhere on here if this is linear or quadratic regression. Both of those are on your reference sheet. So I'm going to just remind you, for linear, it's mx1 plus b. And for quadratic, it's the y1 tilde, and then it's standard form. So it's ax1 squared plus bx1 plus c. And then you can see which one is a better fit. Because when we're doing regression, remember that r squared value, you want it to be as close to 1 as possible. So look at when I did the linear regression, my r squared is only 0.2. It's going to be a number between 0 and 1, and you want it as close to 1 as possible. So 0.2 is far from 1 on the scale of 0 to 1. Okay, but the quadratic, look at your r squared. It's exactly 1. That means this is a quadratic model. So I'm going to go ahead and get rid of this linear. So here's my data, A, B, and C, to help me write the equation to represent this. Okay, and so then I would type out negative 0.5, because that's my A, okay, x squared, and then plus B, so plus 22x, plus C, but C and C is positive, so it's plus 658. So here's the equation that I've come up with using regression, and then they're asking for the maximum, okay? To maximize the company's revenue, how much should they spend on advertising? Okay, advertising budget, that's X. So they want to know what is the X for the maximum of this graph. So I graphed this over here. I'm going to have to zoom out to see it. There it is. We're looking for the maximum. Okay, so way up here, here's my maximum. I don't know why that's giving me that point. That's not a maximum. Oh, there's, okay. So the maximum is at 900. And X is 22 when the maximum occurs. So X, remember, represents the advertising budget in thousands. Now it already says $1,000. So we're still just going to write the 22. So our answer here should be 22. So 22,000 would be the ideal X value that would give us the maximum revenue. Okay, so we did quadratic regression and then found the maximum. Now, while we're talking about regression, I want to point something out that I found out today. And I think it's new because I feel like I would have noticed this before, but maybe I didn't. So these are the steps listed on your sheet for regression. Okay, you make the table, you type this in, then you type your equations with that A, B, and C in, etc. Right? That's what we've been doing for regression. But I'm going to delete these last two. Because what is here when you insert a table of values, when you create this table of values, do y'all see this little line through the points up here? Okay, if you hover, it says add regression. It'll add the regression for you and you don't have to type anything in. And it gives you a drop down. Do you want linear regression or any of these other types of regression? And you can just quickly check. Okay, linear regression, R squared is only 0.2. Ew, gross. No, that's not it. Quadratic, hey, R squared is 1. That's what we want. And it gives you the equation already that we came up with before. And you don't even have to type that. Okay, so one, it's graphing it for you, so you don't have to type it out. There you can see 22,900, same maximum. But if you wanted to type it, because if you wanted to plug in a number, you can just click here where it says equation, and it will paste that equation into the next line. And then you could plug in for X, whatever you wanted to. Mm-hmm. So that's a little shortcut for the regression where you don't have to type anything in. Now, I want to go back because after recording this in another class, I went back and looked at it more and figured out the mistake because I was thinking there had to be a typo or a mistake or something with number. So you can go back and look with me. I think it's number 27. So 26, 27, and 28 are all regression questions. But in 27, it's saying you have a budget of 40. This is actually very similar because it's an advertising one. But it's comparing two companies to see which company you should go with if your budget is 42,000. So we did the regression for both companies. We looked at linear, we looked at quadratic, and the R squared was better for quadratic. And so we did the equations for quadratic, and it came out that company B was better, but the difference was not one of these answer choices. So I didn't even circle an answer because I figured there was a typo or something somewhere. But when I went back and looked at it with linear, these answer choices, there was a correct answer choice if we ran them as linear regression. So I just want to go and show you in what I mean when I say why I chose to do. I put in like company A here. So add a table. This is 19, 17, 22, 26, and 33. And then the Y's are 72, 67, 133, 140, and 151. Okay, so again, we just click here to get our regression. You'll notice linear regression is R of 0.75. Do I have any typos or is this good? 17, 22, 26, 33, 72, 67, 133, 151. Okay, it's only 0.7573. And when you choose quadratic, it's 0.9208. So definitely quadratic is the better fit. So that's what we should be using for this one. But when we do that, there's no correct answer choice here. But if you do it with linear and you write these equations, now I'll do company B. 33. Okay, the linear is much closer for this one. It's 0.95, but quadratic is also 0.99 for this one. So even though the linear is decent for this one, quadratic's even closer to 1. So on both of these, technically, when we use quadratic, we don't get those answer choices. So I think it was a mistake in the writing of the question, whoever wrote this question and put it in here. They used linear when they came up with the answer choices, which you shouldn't have used linear. You should have used quadratic. But if you do use linear, you end up, what you have to do once you have your equations is plug in 42, because that's what they want to compare. So you plug in 42 in place of X. In both company A and company B. And because it's already in thousands, so 42,000, we just plug in a 42 and we get like 214 and 181. And you can see the difference in 214 and 181 is, well, if we typed it in, oh, that one's closer to 182. So let's type in 182. It's about a $32,000 difference. And company A was higher. So running this as linear regression, you actually get answer choice C as the correct answer. So that's what AWARE is looking for. But I just want to point out that that question, there's a lot wrong with that question, because definitely quadratic should have been used, and it shows company B would be better if we did quadratic for both of those, because for both of those, the R squared was closer to 1 with quadratic regression. So that is not a pretty question. I'll just tell you the answer choice is supposed to be C and AWARE, because it was set up as linear. So just keep that in mind. Number 27 in AWARE is going to be C, but really there's not a correct answer choice there if you ran it as quadratic, which it should be. We'll make sure the test should not have an error like that in any of the questions. If you're doing the test and you come across one and you think there's something like that, of course, point it out to me and I'll check it, but I don't think it's going to be an issue on the exam. But I just wanted to point that out while we were talking about regression. So in AWARE, they want you to say answer choice C, a difference of 32,000 with A being the better. But okay, get back down to where we were. So that we answered 33. So last one, 34. It says write the system of equations represented by the table below. Okay, so you could do linear regression to come up with these equations, and I know it's linear because all of these are well, actually, this answer choice is quadratic, that answer choice is quadratic. So they're wanting you to check and see which one fits best. So answer choice A has 2 linear, and then all the rest have 1 linear and 1 quadratic. So you could check these by plugging the numbers in and seeing which one works best for both equations, or you could run regression, which I would just run regression, especially now that we know that little shortcut's in here for regression. It makes it not take quite as long. So I'm going to enter my table A. So -2, -1, 0, 3, 5, 11, 4, -1, 4, and 4. And when you enter a table, you'll do realize it does create a scatter plot for you. So you can see these points on the scatter plot here from this table. Now, if we run the regression, there's linear regression and r squared is 0.2. Not good. But quadratic, r squared is 1. Hey, look, when we run it as quadratic, that parabola hits all of those points that were from that table. Okay, so that one's definitely quadratic and it tells you the equation. So it should be x squared minus 4x minus 1. So x squared minus 4x minus 1. That's in answer choice B and D. So we've narrowed it down to B or D. Okay, so we can eliminate. I don't know why my pen's not working here. Okay. Can eliminate B's A and C. On 10. Okay. All right, so now we'll just run the regression for table B and see which one has that correct. Oops. Green. So I'm going to clear those out. It's going to be -2. Oh, I guess I need to enter a table first. That would be smart. Now type in my values. -2, -1, 0, 3, and 4. -2, 1, 4, 13, and 16. And then we can click here to get our regression. Okay, linear is a 1 for r squared. That's what we want it to be. I mean, you're welcome to double check quadratic. Oh crap, they're both 1. Oh, well, look at this. On the quadratic, when it says r is 1, look at your a value is 0. So that takes out the x squared and is still linear. So it's still 3x plus 4, okay, whether you show it as linear or quadratic. So it's just 3x plus 4, which is this bottom one. 3x plus 4, not 4x plus 3. Okay, so we had to do regression for each and see was quadratic or linear the best fit for that data. And then the calculator wrote the equation for you. You could work backward from your answer choices. If you wanted to plug all those numbers into your answer choices and check, you could. But remember, the steps for quadratic regression and linear regression are here on this reference page that you get. So if you want to make a note somewhere on this reference page next to regression about how Desmos, in Desmos, you can just click on, like when you have your table entered, if you want to click on that symbol where it's got like the line going through the scatter plot, if you just click there, that will add your regression. And then you can quickly check linear versus quadratic, and you're looking for the r squared closest to 1. Okay, that's not on here. The steps to do the regression are on here. Knowing how to choose which regression, knowing you're looking for r squared closest to 1 is not here. That's something I would add in the margins if I were you. Okay. All right. So continue working on your review. Again, this is our schedule. So 7th period, we're not testing till Friday. You've got plenty of time. And in our Canvas, we've got all the videos going over all the rest of those problems. The one you're currently watching is video 5. It's going to be here in just a second. But that's it. Just finish up your review. You can check everything against these videos. There's no reason not to have your review and aware completed and a 100. Okay, if you submit it and don't get a 100, feel free to email me and ask me to reopen it. Or if you're in here right now and need me to, I'll do it now. And I'll reopen it however many times you'd like, so you can keep working those and correcting your mistakes. The last thing that you can do to get your Q2 grade up is test corrections or retakes for the unit tests. So if you have not done Unit 4, Unit 5A, or Unit 5B test corrections, you can still do that. Even if you passed, you can do test corrections. And then if you were still failing after corrections and you would like to do a retest, you can do a retest still. You'll just have to come in those optional review sessions in the afternoons these next 3 days.